It's amazing how much data is being sent around the world these days. I'll just tell you one example, like in a aircraft. So a lot of sensor data coming at it. And think about an aircraft that might have threats around it in an RF contested environment. So you might be, getting signals to satellites. You might be getting signals from other aircraft or to the ground. So you think about all these types of signals that are happening, things that help you understand your weather, things that help you understand other objects around you. You're transmitting passenger data. So to make that work in rugged environments, vibration environments, outer space radiation environments, we have to enable computing pretty much anywhere. In other words, if you have a circuit board talking to another circuit board and it has to go through the connector, any change in metal, plastic, or air can disrupt that signal. And so we have to design high-speed connector products, whether the connectors or cable systems or the terminations, very carefully. And we do our simulations through those. We try not to affect what we call the insertion loss or the power of the signal as it goes through. But we have some technologies where we can boost that signal so we can understand the signal health. We can clean it up, take the noise out of it, and then boost it so it can continue on the path. We can do that through copper cables. We also do it through fiber optic signals. What we're seeing in our industry is more power is needed because more sensors are being connected, more passengers need to be charging, just a lot of inputs like that. Some of the radar systems have more sensors. So that is really driving a lot of demand for power. So the challenge then is with getting more amps usually requires more copper material or more conductor material. And the other side of that equation is if you can't afford to add more weight, you can increase your voltage. That's when we talk about power. We have to think about taking a lightning bolt and controlling that. Okay, so these are some of these high voltage types of applications where when we deal with high voltage, we have to break it into pieces on power switching, power transmission, and then doing things like power distribution. There are different phenomena that happen once you start increasing things like voltage. All this new technology as power increases really has to be vetted properly, tested properly. We need to understand the conditions our products will be put in. High power, I think, is an extremely growing area in our industry, especially when we're changing propulsion methods. And we're changing from things like traditional fuels to now battery powered and electric powered. You take for granted that all this stuff usually works pretty seamlessly. So we are in the backbone of all that technology. So the power being generated on the engines comes through TE cables. And your in-flight entertainment systems comes to you care of TE cables and connector products and power switching products, the things that keep you safe. So the connectors and the radar systems and the satellite connectivity, all these things are part of what TE provides. The displays that have the pilot information, we make connectors in the graphic modules that are connecting all that. All the ground systems that are communicating to these products. So it's such an exciting time because you see this technology insertion into all these different parts of your life. When you walk outside and look up at the things flying, and sometimes at night, if you take a walk out right after dusk, you'll see some of these satellites reflecting off of the sun. And we're in there. We're in these satellites. We're making them work. We're one of the prime connectivity companies making this stuff.